Right, so our next topic is optics. So basically, light when interacts with any material is a matter of interest. We will be usually studying this light matter interaction. The sense of vision also comes only when light interacts with rods and cones in our eyes. Okay, so this light matter interaction, after this light matter interaction, if we study the properties of light, that branch of physics is called optics. And if we study the properties of material, it is spectroscopy. So light matter interaction lead to two branches. One is optics, another is spectroscopy. So optics studies the properties of light and spectroscopy studies properties of matter. Okay, so this optics is majorly classified into three levels depending on the size of the material and wavelength of light. So one is geometrical optics, another is wave optics, and finally photonics. So in geometrical optics, the size of the object is very large compared to wavelength of the light, like lenses, prisms, mirrors and all. The properties we study under geometrical optics are reflection, refraction, scattering. So some special cases like dispersion. Dispersion is an application of refraction. Dispersion, total internal reflection. So like that, if the size of the object is very large compared to wavelength of light, we consider it as a ray model. So geometrical optics is also called ray optics. Light is considered to be traveling in the form of rays. So in this case, the detail of wavelength information is not necessary. Even if you use, you will get the same result, but it is mathematically complicated, and that much detail is not necessary. So coming to next one, wave optics. If the size of the object is comparable to wavelength of light, the wave nature of light matters. So here we will come across slits, edges, grating, like that. So the properties we study here is interference, diffraction, polarization. So here the wave nature of light matters. Because the size of the obstacle is comparable to the wavelength of the light. Next one is photonics. So here the size of the object is very small compared to the wavelength of the light used. So in this case the light will be interacting with the electrons, the molecules, atoms, etc. So the phenomena that we come across are photoelectric effect, Compton effect, so in this session we majorly focus on wave optics, where size of the object is comparable to the wavelength of the light used. So we will come across interference, diffraction, polarization phenomena. Okay. So interference. Interference deals with the superposition of light rays from two coherent sources. So coherent means identical. Next one, diffraction. Diffraction is due to superposition of light rays from a single source. Or on multiple sources. From 2 points on same wavelength. Light waves. So we should call them as light waves. So diffraction is due to superposition of light waves from 2 points on a single wavefront. polarization it is the unidirectional nature of electric field vector of light rays. So light is considered as electromagnetic wave. So there will be mutually perpendicular electric and magnetic fields. Let's say this is electric field. This is a magnetic field. So this is a electromagnetic wave where electric field and magnetic field vectors oscillate in mutually perpendicular directions and perpendicular to the direction of propagation of light. So electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation. So we'll have infinite possibilities for this orientation of electric and magnetic fields. They both are perpendicular and perpendicular to direction of motion. So we'll have infinite possible orientations for electric and magnetic field vectors. And out of that, if we choose one or a few, then we call it as polarized light. That is unidirectional nature of light. So all these properties can be explained only by wave nature of light. So we'll see the details of interference, diffraction. So now, what is the origin of light? How light is generated? Light ఎట్లా జనరేట్ అవుతుందండి? ఎలక్ట్రాన్స్ జనరల్గా ఆన్సర్ మనకు తెలిసిందే. ఫోటాన్స్. సో ఫోటాన్స్ రిలీజ్ అయితే లైట్ జనరేట్ అవుతుంది. ఫోటాన్స్ ఎట్లా జనరేట్ చేయాలి? So it is Bohr's third postulate. When electron jumps from higher energy level to lower energy level, the difference of energy is emitted as photon of particular frequency. Okay, so photon is basically a wave packet. Okay, so now we'll see a brief detail of photoelectric effect and try to understand what is photon. Then we'll go into rest of the details. So, what is photoelectric effect? Light falls on a metal, electrons are emitted, electricity is generated. Yeah. So, ఇందులో కండిషన్స్ ఏంటంటే when light of particular frequency falls on a metal, photon completely disappears and electron is emitted. So it is basically an elastic collision. Elastic collision onto a tightly bounded particle. సో ఎలాస్టిక్ కొలిజన్ ఏమవుతుంది, ఒక ఆబ్జెక్ట్ కంప్లీట్గా రెస్ట్లో ఉంటే, ఒక ఆబ్జెక్ట్ మూమెంట్లో ఉంటే మొమెంటస్ విల్ గెట్ ఎక్స్చేంజ్. ఎలాస్టిక్ కొలిజన్ ప్రాపర్టీ ఏంటంటే మొమెంటం గెట్స్ ఎక్స్చేంజ్. సో ఫోటాన్ రెస్ట్లోకి వస్తే ఏమవుతుంది, what happens if photon comes to rest? మనకి రిలేటివిస్టిక్ ఎనర్జీ ఈక్వేషన్ ఉంటుంది, E² is equal to P² C² plus m02 C/4. Okay, m0 is the rest mass of the object and this is momentum. P is the momentum. Okay, so photon has no rest mass. అంటే మనకి ఆబ్జెక్ట్ కనుక మూమెంట్లో తీసుకొస్తే దానికి బేసికలీ ఆబ్జెక్ట్ విల్ హ్యావ్ సర్టెన్ ఎనర్జీ వితౌట్ మూమెంట్. దాన్ని రెస్ట్ మాస్ ఎనర్జీ అన్నారు. వెన్ ఇట్ కమ్స్ ఇన్ టు మోషన్, బికాస్ ఆఫ్ ద కైనెటిక్ ఎనర్జీ ఆర్ మొమెంటమ్, ఇట్ గెయిన్స్ సర్టెన్ అమౌంట్ ఆఫ్ ఎనర్జీ. అంటే మామూలుగా స్టోన్ ఒకటి ఉంది, అది మన చేతిలో పెట్టుకుంటే పెద్ద ఎఫెక్ట్ ఉండదు, అది ఎవరైనా ఇసిరేసారు, ఇట్ హిట్స్ us హార్డ్లీ, ఇట్ విల్ హావ్ సర్టెన్ ఇంపాక్ట్. సో ద రెస్ట్ ఎనర్జీ is different from kinetic energy. Alright, so this equation separates both of them and deals with them separately. This is rest mass energy, this is kinetic energy. Okay, but for photon rest mass is 0. Rest mass of photon is 0, so energy is peace. So if we draw a dispersion curve for this, dispersion curve గురించి కూడా అక్కడ డిస్కస్ చేసాం. A graph between energy versus moment T. We get a straight line for photon. Okay, so now what happens if photon comes to rest? Photon comes to rest, it completely disappears. Right? There is no identity or rest mass for photon. So photon exists as long as it is in motion. It disappears if it stops. So photoelectric effect lo emoutundi ante the photon interacts with an electron which is tightly bounded to the lattice. So the electron is assumed to be at rest initially and elastic collision is assumed. Okay, during elastic collision momentums exchange, so photon comes to rest and electron comes to motion. So photon disappears completely and electron comes into motion. Whereas the other case, Compton effect, in Compton effect, here also we consider a complete elastic collision, because we are able to apply conservation of momentum. Momentum conservation is applicable only in elastic collisions. So perfect elastic collision. But here in this case, photon still exists with lower energy after collision. So in Compton effect, there comes an incident photon. It ejects an electron from the material. At the same time, photon still exists after collision. So collision తర్వాత కూడా photon exist అవుతుందంటే దాని అర్థం ఏంటి? ఎలాస్టిక్ collision అంటున్నాము అంటే momentums exchange అవ్వాలి. So that implies the electron is in motion. Electron is loosely bounded to the lattice. Electron momentum and photon momentum exchanges. That is about Compton effect. The rest of the details we will see in modern physics. Now coming to photon and photoelectric effect. So I have seen. So what is photoelectric effect? When light falls on a metal, electrons are emitted with some kinetic energy, right? So some of the energy is used to overcome the binding energy of the electron. So electron is bonded to the atomic lattice or whatever material. So some energy is required to eject the electron from the lattice, and rest of the energy is converted to its kinetic energy. Now what happens if I increase the so here each photon ejects one electron if it has sufficient energy. So the equation is so photoelectric effect equation ఏంటంటే h nu is h nu naught plus half mv square. So this is the binding energy. Or you can even call it as work function. So the sum is utilized to work on binding energy, the rest is converted to kinetic energy because photon completely disappears. It transfers entire its energy to the electron. So now, so each photon ejects one electron if it has sufficient energy. Now comes the question, if I increase the frequency of the photon, what happens? So there are two possibilities, frequency and intensity. Frequency of photon and intensity of photons. So depending on that, what happens to number of electrons and energy of each electron need to be discussed. So what is frequency in general? What is the dictionary meaning of frequency? So I'm asking about frequency of photons. Photon is a single entity, a countable entity. Now what is frequency? Let's say frequency of buses in a route. So ఈ రూట్లో బస్ ఫ్రీక్వెన్సీ ఎక్కువ ఉంది అంటే ఏంటంటే నెంబర్ ఆఫ్ బస్సెస్ ఎక్కువ ఉన్నాయి. సో if I raise the frequency of photon, what happens? Number of electrons should increase. I mean general logic. With the rise in frequency, number of photoelectrons should increase. General estimation. And if I raise the intensity of light, general, then intensity pencha. Energy of so it may be reflecting in the energy of electron, right? So if I raise the intensity, usual general logic says energy of each electron should increase. But when people did this experiment, quite opposite results were observed. With the rise in frequency, energy of the electron is increasing, electron count is not affecting at all. Okay, so with the rise in frequency, electron count is increasing. Sorry, kinetic energy of electron is increasing. Number is constant. And with the rise in intensity, number is increasing, kinetic energy is constant. Okay, so the equation is generally frequency and T. General meaning of frequency is number of certainties. So if I raise the frequency of photon, usually count should increase. I mean, the first thought that comes to our mind is photon count increases, so we'll get more electrons. But that's not happening here. So we have to define a frequency for a single photon. So here the equation says a frequency is defined for a single photon. So frequency does not mean frequency is not the number of photons, but frequency is defined for single photon. సో ఇక్కడ ఈక్వేషన్ కూడా అదే చెప్తుంది. ఫ్రీక్వెన్సీ ఇస్ డిఫైన్డ్ ఫర్ సింగిల్ ఫోటాన్. ఎట్లా డిఫైన్ చేయాలంటే హై ఫ్రీక్వెన్సీ ఫోటాన్, లో ఫ్రీక్వెన్సీ ఫోటాన్. So if the photon is generated during a transition from large energy gap transition, then its frequency is high. Frequency is number of waves. I mean, photon is a wave packet, and the number of waves in that packet is defined as frequency. So if this takes place from a low gap transition, then the number of waves is low. Here the number of waves is high. So this is high frequency photon. This is low frequency photon. What about intensity? I'm trying to raise the intensity of light source. How does it affect the nature of photon? Intensity ante entante square of amplitude. So they have a frequency antunam kada, number of waves. Intensity is square of amplitude. Maximum displacement దీన్ని వర్టికల్గా స్ట్రెచ్ చేస్తాం. Then how to rise the intensity? ఒక వేవ్ ఏదో ఇచ్చారు, దీని యాంప్లిట్యూడ్ని రైజ్ చేయాలి. ఎట్లా పెంచుతారు? So we use construct interference to rise the amplitude. So if two waves interfere constructively or superimpose constructively, the amplitude of the wave increases. So construct interference is the process to generate or to increase the amplitude of a wave. So if two photons superimpose in the same phase, we get a high intensity photon. So high intensity photon actually carries more than one photons. So with the rise in intensity, number of photoelectrons increases. So high intensity photon is actually a construct interference, as a result of construct interference between two or more photons. This is a construct interference.